This video presentation is brought to you by the ProMathAcademy. Welcome to another video presentation brought to you by the ProMathAcademy. In this video, we'll be looking at linear equations, and when we talk about linear equations, we are talking about equations that have their unknown term or the term we are solving for being raised to the first power, okay? That definition is not the exact definition of a linear equation, but that's what we will be working with for now, right? And in this video, we'll be demonstrating how to solve the basic and intermediary linear equations. Moving right along to the examples that demonstrate how to solve basic linear equations, we have example number 1, x divided by 2 equal to 3. And to solve this, we need to recognize that we need to transpose for x, right? That is bringing 2 from the left-hand side over to the right-hand side. Thus, we have x being equal to 3 multiplied by 2. Thus, x is equal to 6, and that is our answer. For example number 2, we have 20 divided by x. This is not a linear equation, but when we take x from the denominator and bring x over to the right-hand side, we notice that we have 20 being equal to 5x, which is now a linear equation. Thus, solving this, we need to recognize that 5 is multiplying x on the right-hand side. Thus, we bring 5 from the right-hand side over to the left-hand side, which gives us 20 divided by 5 equal to x. Thus, x is equal to 4. That's our final answer. Example number 3, we have x plus 3 being equal to 10. Thus, transposing for x means we have to bring 3 from the left-hand side over to the right-hand side. Thus, we have x equals 10 minus 3, which means x is equal to 7. Example number 4, we have 25 minus x being equal to 17. Since x is on the left-hand side, we want to bring x over to the right-hand side, making it a positive term. Thus, we have 25 being equal to 17 plus x. Thus, 25 minus 17 is equal to x. If we recognize that on the right-hand side, we are adding 17. If we're transposing for x, we will be subtracting 17 from the left-hand side, giving us 25 minus 17 equals to x. This means 8 is equal to x, giving us our answer. Please make a note that whenever x is on one side of the equation and it is negative, we want to bring it over to the opposite side of the equation, making it positive. Now we move right along to intermediary linear equations, and we want to define an intermediary linear equation to be the set of linear equations that require more than one step in transposing or requires us to use the distributive property of numbers. All right, so we take example number 1, right? For example number 1, we have 7x minus 2 equals 2x plus 13. Right here, we have 7x on the left-hand side and we have 2x on the right-hand side. We want to bring both terms in x on one side of the equation. So I'll take 2x and bring it to the left-hand side, and I'll take negative 2 and bring it over to the right-hand side. Thus, I have 7x minus 2x equals 13 plus 2, which means that 5x is equal to 15, implying that x is equal to 15 divided by 5, right? 5x equals 15. That is a basic equation. And to solve that basic equation, we have demonstrated this in the previous set of examples. We simply divide by 5 on the right-hand side, thus giving us x equals 3. Example number 2, we have 4 times 2x plus 1 equals 20. Using the distributive property of numbers, we can distribute 4 over the sum of 2x and 1. That gives us 8x plus 4 equals 20, which means that 8x is equal to 20 minus 4, bringing 4 from the left-hand side to the right-hand side, which means 8x is equal to 16. That is the difference between 20 and 4. And now we end up with a basic equation. And to solve that basic equation, we simply divide 8 on the right-hand side, since on the left-hand side, 8 was multiplying, thus giving us x is equal to 2. Example number 3, we have 8 minus 5 times 2 minus x being equal to 8. Thus, my first step involves distributing that negative 5 over the difference between 2 and negative x. So this gives us 8 minus 5 times 2 plus 5 times x, because it's a negative 5. When the negative 5 distributes over the expression, the signs on the inside of the bracket will change, thus giving us that left-hand side expression being equivalent to 8, right? And if we look at this, we realize that we can bring 8 over to the right-hand side, and we can bring negative 5 times 2 over to the right-hand side, giving us 5x equals 8 minus 8 plus 5 times 2, which is equivalent to 5x equals 0 plus 10, which means 5x is equal to 10, which means x is equal to 10 divided by 5, giving us x equals 2. Example number 4, I have 7 times x plus 3 equals 9 times 2x minus 1 minus 3. All right, so first we want to distribute our 7 over x plus 3. This gives us 7x plus 21 being equal to 18x minus 9 minus 3 after distributing 9 over 2x minus 1. Then this implies that 21 plus 9 plus 3 is equal to 18x minus 7x after bringing 7x from the left hand side over to the right hand side. This then gives us 21 plus 12 is equivalent to 11x, which means 33 is equal to 11x, a basic equation, which means that 33 divided by 11 is equal to x, thus demonstrating that an intermediary linear equation can be simplified down to a basic linear equation, and then we can solve that simply. Please remember to like, share, and subscribe. We'll see you in the next video.